Hi.
Hi.
Who are you?
I'm John Fonner. I've been at the Texas Advanced Computing Center for 12 years now.
Wow.
And currently serve as the Director of Special Projects. My background is in life sciences computing. And really what I love about TACC is that we treat computing like an ecosystem.
Okay.
And a lot of my job is trying to make that ecosystem easier to use for researchers, and especially researchers that don't traditionally use high-performance computing.
Okay. So tell me about, so you usually you're teaching containers. And you were talking to me about recipes a few minutes ago, but we didn't really get into it.
Sure. We really love software containers. And the analogy I like to make is, what is your favorite food that you like to go out and eat? Pho. Okay.
You call it pho, not pho.
Okay, I'm with you. So, pho, right? Soup, a lot of ingredients. Do you like to cook it at home?
No.
Right.
No, I do not.
Right. So the thing is, just in the same way that we can want to eat food that we can't necessarily make ourselves, we have this with software as well. There are lots of researchers that need access to software, but that doesn't mean they can necessarily start with the ingredients and compile it and build it and create an environment, manage all the dependencies themselves. And so we've been using software containers to overcome this gap. It's like takeout for scientific computing. And
okay, so tell me, containers are what?
So a software container is a software package that you're interested in, as well as all of the dependencies that you need to run it, the libraries and the various things that piece of software is built on top of.
Okay.
So every new user to TACC, right, they've made their login, they get an allocation to run on our system, they log in for the first time, and suddenly they need their data, and they need the software that they care about. And so thousands of times a year, we have users that are working to try and figure out how to install the software that they want to install. We have a module at TACC called Apptainer, and that lets users just pull in a container, which is just like pulling in a file or pulling a Docker image, and it has everything in it already pre-cooked, so they don't have to worry about building their software package.
Oh, very cool. Very fun.
So we think this is great. And it provides a lot of portability between systems. So a lot of times projects will start on one system and move to another. And if their software is in a container, they can just move the container to the next system and continue on with very little transition. And as well as communicating research results. There's a lot of difficulty with reproducibility in research computing right now. One lab publishes a paper on something they've done, and then another lab tries to reproduce that work, it doesn't get the same results. And we feel like containers are part of a solution to that as well. So if when you publish your paper, you can say, here's my container, and here's the command I ran to get the results that I obtained, then another group will only have a couple of steps to try and reproduce that result. And we think this is much better. We offer training many times a year on containers, but we also put that training online. It's containers-at-TACC on readthedocs.io.
Yeah.
And
wait, so is this link going to be on there? Okay.
We're pretty happy with how that training is coming along. If it's your first time ever using containers, we'll show you what they're about. We'll give you hands-on examples that you can run with them. And even for experienced users, we delve into topics like, how do I use containers when my application is massively parallel using MPI? Or how do I use containers that require GPU access?
Okay.
And other types of things like that.
Other types of things like that.
Like GitHub Actions integration for automatically deploying containers and other things.
Okay. Thank you, John.
Sure.
All right, this is John Fonner. He works here.